All right, guys, as you can see, I am running super short on time here, but what I figure is that a lot of students are not going to be here today. And so, to account for that, I'm going to make a video. For those of you that are in class, you can watch this video, and if you miss class, then you have this video that you can check out for the notes today, and we'll have a little bit of homework on Khan Academy. All right, so today I'm going to talk about the power rule, and I'm also going to talk about some other derivative rules. So we'll check this out, and this is actually combining a couple different sections of the AP curriculum, and we'll see how much we can get through here. So first of all, let me give us some derivative rules. We're going to move away from using the formal and informal definition of the derivative today, and we're going to be able to take some derivatives super fast. So first of all, though, some basic derivative rules. Here's my first one. If I take the derivative of a standalone constant, I want us to think about what the graph of a constant looks like. For example, if I wanted to graph a line y equals 7, the line y equals 7 is a flat line, which means the slope of this flat line is 0. So the derivative of any constant is always going to be 0. That's my first derivative rule. Second derivative rule is this. If I take the derivative of c times some function f of x, and I'll put a little caveat here where c is a constant. Okay, so in other words, or constant, we'll say constant coefficient. All right, so for example, if I had like y equals 7 times x, right, this number right here is what I'm talking about. What I can do is I can take this c value out to the front, and I can make this c times d dx of f of x, or if you want to look at some nicer notation, c times f prime of x, right? So I can take a constant coefficient, I can move it out to the front. And we'll do an example where we try this in just a moment. All right, next up, last derivative rule here. Keep my colors consistent. d dx of, if I try f of x plus or minus g of x, what I can do with this is I can take the derivative of these separately. So this would be d dx of f of x plus d dx of g of x. Or if you want to write this in nicer notation, not Leibniz notation, but Lagrange, this would be f prime of x plus g prime of x. All right, quick example here with this. Let's check it out. Let's try this. Let's say I told you that f of 2 was 5, f prime of 2 was 4, g of 2 is negative 3, and g prime of 2 is 2. And then let's say that I told you that h of x was equal to 3 f of x plus g of x minus 7. All right, so the question I want to ask is, what's the equation of tangent line to h of x at x equals 2? Okay, what's the equation of the tangent line to h of x at x equals 2? All right, we talked about this the other day. In order to find the equation of a tangent line, we need two things. We need a point and we need a slope. So let's begin this problem by finding the point. Here's what I would do. If I want to find the point, well, let's plug in 2. So here's what I've got. Everywhere I see an x, I'm going to plug in 2. And we should have enough information to do this as presented, because we were told that f of 2 was 5, so I'm going to replace this with a 5. And we were told that g of 2 was negative 3, so I'm going to replace this with a negative 3. And I'll do some math. So 3 times 5 is 15, minus 3, minus 7, that's 12 minus 7, that is 5. So therefore, my point is 2, 5. All right. Now, next up, I need to find the slope. Well, how do I find a slope? Well, a derivative is the slope of a tangent line. So what I first need to do is I need to find the derivative of this function. Well, let's use some derivative rules. We just learned that if I'm taking the derivative of a constant coefficient times a function, I can take the constant to the front. So this would be 3 times f prime of x. Derivative of g of x would be g prime of x. And we just said that the derivative of any standalone constant is just 0. So you can write a plus 0 there, but you don't have to. The derivative of that is 0. Now that I've got this derivative, now I can find what's h prime of 2. Well, let's try it. This would be 3 times f prime of 2 plus g prime of 2 plus 0. And I should have enough information to do this as well, because it was presented to me here that f prime of 2 was 4 and g prime of 2 was 2. So I'm going to go ahead and plug those in. F prime of 2, this is 4. G prime of 2 is 2. So let's try it. 3 times 4 is 12, plus 2 plus 0 is 14. So my slope of my tangent line must be 14. Right? So with all this in mind, here's the equation for a line. And if I want to plug information in to write the equation of this line, this is going to be y minus 5 equals 14 times x minus 2. So there's the equation of my tangent line. So there's some basic derivative rules, and we're putting them into play right there to help us find the equation of a tangent line. All right, main part of today, and I've got about 8 minutes to lay this out, or a little more, we'll see. I want to talk about something called the power rule. I'll give you some examples, and then Khan Academy will be for homework. We'll see what you guys think on the Khan Academy. All right, so power rule says this. I'll give some various examples as we go. Power rule says if I am going to take a function like x to the n power and take its derivative, the derivative of x to the n power is I take this exponent and I multiply it to the front of the term. So this is going to be n times, and as I move along here, what I do with the exponent is I subtract 1. So this is going to be n minus 1. Okay, this power rule works anytime I'm taking a variable and raising it to some numerical exponent. I take the exponent, multiply it to the front, and then I subtract 1 from the exponent. So really basic example here. I'll do a one that's a little bit longer. Let's say that we had f of x equals x squared. Okay, if I wanted to take the derivative of this, I'll do this in 2 steps. I could take this 2, multiply it to the front. This would be 2 times x to the, and I'm going to take that exponent and subtract 1. So this would be 2 minus 1, which you don't have to write that because in our head we know 2 minus 1 is 2x to the first power, which is just 2x. Okay. If I wanted to extend this a little bit further and do f double prime of x, well, f double prime just means I'm taking the derivative twice. Well, let's look. The exponent on this x is an understood 1, so if I multiply that to the front, I multiply it by the 2. 2 times 1 is 2 times x to the, and we'll be able to do this really fast, but just to show you how this works, subtract 1 from the exponent. 1 minus 1 is 0. And guess what? Anything to the 0 power is 1. So this is really just 2. Right? So if I go down the progression, if I start with x squared, the derivative of that is 2x. And the derivative of 2x is 2. So bigger example here. Oops, sorry. Let's say that I wanted to do f of x equals 3x to the 5th minus 4x squared plus 2x plus 11. And let's say I want to take this derivative. Okay, here's what I would do. Multiply the 5 to the front. 3 times 5 is 15. Subtract 1 from the exponent. I get 4. Minus 4 times 2. To take this 2 and multiply it to the front is 8. Subtract 1 from the exponent. So this exponent is now 1. 2x. If I ever have one that just has an x, the derivative of it is just the coefficient. And then the derivative of 11 is 0. Okay, so if I wanted to simplify this a little bit, just write 15x to the 4th minus 8x plus 2. There's the derivative of f of x. Okay? All right. Hopefully you understand that power rule. One note I would like to make, and then I'll show you a couple of examples to close out, is that this works for negative and fractional exponents as well. All right. So here's my example of this. If I saw something like f of x equals 3 over x to the 5th, my number one rule, and you'll hear me say this a bunch of times, what I want to do with this is I want to rewrite this like 3x to the negative 5, because a negative exponent means it just flips down to the bottom. So this is what I have. F prime of x has to be, I take this negative 5 and multiply it to the front. This becomes negative 15, x to the, and then I take this exponent and I subtract 1. So this is going to be negative 6. From here, what I can now do is I can rewrite this as negative 15 over x to the 6th. So there is the derivative of 3 times x to the negative 5. So always rewrite negative exponents like this, and then you can go from there and use the power rule just like before. This also applies if I have some sort of fractional exponent. So let's say, for example, that we were doing the 11th root of x to the 8th power. Now, you might not have seen this for a while, but the 11th root of x to the 8th power can be rewritten as x to the, take the power, divided by the root. So this is x to the 8 over 11 power. And I'm always going to tell you, anytime you're taking derivatives, rewrite it this way, because now the power rule is simple. I take this 8 over 11, multiply to the front, so it's 8 over 11, times x to the, and then I subtract 1 from the exponent. Well, 8 over 11 minus 1 is negative 3 over 11. Now, I would accept this as a final answer. If you wanted to leave it like that, that would be fine. However, we do need to be able to find an equivalent form of this. So, if we wanted to do this in a couple steps, if I want to get rid of the negative, move it down to the bottom. And then I could rewrite x to the 3/11th as the 11th root of x cubed. So here would be my final answer for this one. Okay? All right, a couple little examples here to close this out. And we'll see how we're feeling. Let's say I wanted us to find, let's say I want to find the tangent line to f of x equals 2 over x cubed at x equals 2, for example. All right, so tangent line, I need a point and I need a slope. First things first, let's find f of 2. So I can find my point. If I do this, 2 over 2 cubed is 8. This would be 1/4. All right, so my point would be 2 comma 1/4. When I plug in 2 to the function, I get 1/4 for y. The next thing I would want to think about is what's the derivative? Okay, well, this function could be rewritten, if I want, as 2 times x to the negative 3. So if I took this derivative, multiply the negative 3 to the front, so this would be negative 6 times x, subtract 1 from the exponent, I get negative 4. This could be rewritten, if I want, as negative 6 divided by x raised to the 4th power. All right, so there's my derivative, and if I want to find the slope of the tangent line at 2, I go to this function, and I plug in 2 everywhere I see an x. So this would be negative 6 over 2 raised to the 4th. So this would be negative 6 over 2 to the 4th is 16. So that simplifies down to negative 3/8. So therefore, my slope of my tangent line is negative 3 over 8. All right. Now, plugging into the equation for a tangent line, this is going to be y minus 1/4 equals negative 3/8 times x minus 2. So there's the equation of my tangent line for this function. Okay. All right, that's all I've got time for right now. I might make an addition to this video, but now I'm going to stop, and I'll see you guys in class in a few minutes.